Okay, let's write that in here. So force vector to the upper right is engine at, what was it again, 6,500 newtons. By the way, this particular example setup is perhaps the most intricate with the most vectors, so the other 8 that or 10 that you have to do should be easier than this one. Okay, so force vectors to the left and lower left, there was friction, and there are 2 of them, and they're both 3,500 newtons. And force vectors up and to the upper left, those were support forces. I think I'm going to roll the page over here before I go on. That looks a little better. And one of them was 4,500 newtons, and the other one was 9,000 newtons. And then force vector down, well, that of course is the weight, and that was 9,000 newtons. Now again, there would be 3 methods of adding these vectors. One is draw them yourself, tip to tail. That of course takes some good dexterity as you are drawing them on paper. I have done that here. So here would be the support force to the upper left, here's the friction to the lower left, here's the support force up, here's the friction to the left, here's the weight, here's the engine force to the upper right, and then the net force is from the tail of the first vector to the tip of the last vector, and that would point to the upper left, and I read off 8,500 newtons for the net force. So 8,500 newtons. The direction would be, well, upper left. The acceleration is 8,500 newtons divided by 900 kilograms, so the acceleration is 8,500 divided by 900, and when you do that you come up with 9 or 9.5 rounded meters per second squared. I don't think I need to show you that on a calculator. And the direction is upper left. Okay, what happens to the car? Well, the car is initially going to the right. That's what it says. Now travels with a speed of 50 kilometers an hour to the right. But the acceleration, which is a change of velocity, is to the upper left, which means to the left means it's getting slower. The car slows down, and a part of the component is up, so that means that the car is also changing direction. So and the car is changing direction, going up, and that of course means that the car is going to make this jump over the bump. Because it didn't have any velocity in the vertical direction before, that change in the velocity as it is going up means also that it's changing direction. So from strictly going right, now it's going to go right and up. Okay, you noticed that these vectors here, That takes quite some, as I said, dexterity in order to add them graphically, so perhaps the other graphing method with the applet is going to come in handy. I'll do that in just a moment. The second one I had mentioned about computing, because these here are at an angle, they're not easy to add as numbers. So I would advise when you come across vectors that are at an angle, that are neither completely horizontal or vertical, don't use that method of adding the vectors on a calculator, but use the graphical method, either doing it yourself here on paper or using the applet that I will use right now. Okay, let's see what we have here. We have an engine force of 6,500 newtons, and again I will scale this to, I think I reset this first. I will scale this to hundreds, so I have 650 newtons to the upper right, which means 45 degrees, and even that is off the picture. Even that is really long. Then I have, let me see if this one here works better, 65. Well, I'll try this one actually, 65. So I scale it down to from 6,500 to 65, so that works in this applet. So to the force vector to the upper right, 6,500 newtons, 45 degrees. Then force vectors to the left and lower left, which is friction. So one of the friction is 3,500 newtons, so 35. To the left is 180 degrees. Then the other one is also 3,500 newtons, but it's to the lower left, which is 180 plus 45. Notice that that does point to the lower left, an angle of 45 degrees down. Force vector up is the support force at 4,500 newtons, so it's at 90 degrees. And I'm going to try to shift all of this here. Then force vector to the upper left at 9,000 newtons, and that is 90 degrees plus 45, 135. So that's that one there. And I believe this applet is actually really slick. I really like this. And I think I have one more, which is the weight of 9,000 newtons, and that points straight down at 270 degrees. There it is. And now show the net force. And just like I had it earlier, drawing it by hand, I come up with the upper left. So it's pointing to, the net force is pointing to the upper left. And this one here would say 8,700 newtons. Well, that's what I had measured virtually as well, doing it on paper. 8,700 divided then by the 900 kilograms gives me 9.5 meters per second squared, and of course the acceleration is in the exact same direction as the net force is. So those were the two examples for these setups for this lab on adding forces.